so these ones, again, we want to use a definition of log, so we want to convert them to an exponent. Notice that it says solve, because notice that in the log form, we can't actually solve for this. However, if we rearrange this into its exponent form, so the base of the log is the base of the exponent, the log is an exponent, so the exponent is 4, and it equals the argument, well, I can solve for x. Okay, x in this case is 81. So log base 3 of 81 equals the power of 4. Here, same thing. If in the log form, I can't solve for this. I can't actually find x. Okay, but if I rewrite this with my base, the log equals the exponent, so there's my exponent. It equals the argument. I can actually solve for x, so plus minus square root 5. Now, anytime we're solving for x, we do have to check to see if the solution is extraneous. And if we plug negative root 5 into here, it's extraneous. So what we have to say then is negative root 5, this is extraneous, and positive root 5, this is our answer. So this one is extraneous. Okay. So again, with these problems, I showed you 2 different ways to do this, but I want you guys to try to use some log properties to isolate the log x, and then we can use the value of log x that's given here as 3.3. Okay, so that's just more of a random value. It could be any value. So 3.3 here, and here the log y is 2.4. So we want to isolate the log x and log y parts of this expression using some log properties. So I'm going to get rid of that exponent by multiplying it onto the front. Okay, that'll simplify to 2/3. That allows me to get the log x by itself. So same thing here. That's a power 3. Square root can come out of the log. Okay, powers can be pulled out of the log. Okay, as a power to power rule. So there's this. So this becomes 2/3. I can replace the log x with 3.3, and I can place the log y with 2.4. Okay, so I got those values from up here. Okay, and I got this one from up here. Okay, and then I can then evaluate this numerically. This is, so what does that work out to be? 2.2 minus 3.6. Okay, so I get negative 1.4 as my solution. Now this could have been done as an exponent problem, okay, but I would rather that you do this as a log problem, try to isolate that log. So here I want to separate the x from the y. Okay, so I'm going to end up with 1/2. Remember that 1/2 applies to the whole log, so everything inside here gets applied. I'm going to separate the log x cubed minus, because it's divide, log y, and I'm going to pull the square root power on the outside as 1/2. Actually, I'll do that in the next step. Okay, I can then isolate the log x. Okay, that's the piece I'm looking for. I need to isolate the log y. Again, here's the piece I'm looking for. And then now I can do my replacement. I get 1/2, 3 times log x, 1/2, that's going to be 3.3. Log y, okay, log y was 2.4. Okay, so again, I'll just highlight that. This is my log x, I replace it with 3.3. Here's my log y, I replace that with 2.4. Okay, and then I can just work out that numerical value. So that numerical value simplifies to 1/2 times 9.9 minus 1.2, so that's 8.7. Okay, so 1/2 times that, that's going to be 4.35, and that's my solution to that. Okay, the main idea though is applying some log properties to get that log x and log y kind of isolated by itself.